Hello everybody. In this episode, I'll be speaking with Jan Leike. After working for 4 years at DeepMind on reinforcement learning from human feedback and recursive reward modeling, in early 2021, Jan joined OpenAI, where he now co-leads the recently announced Superalignment team. For links to what we're discussing, you can check the description of this episode, and you can read the transcript at axrp.net. Welcome to Axrp.
Thanks a lot for having me.
Yeah, not at all. So first of all, I guess we're going to be talking about this announcements of the Superalignment team. For people who somehow haven't heard of that or haven't read that blog post, can you recap what it is and what it's going to be doing?
Yeah, I'm excited to. So basically, we want to set us an ambitious goal of solving alignment of superintelligence within the next 4 years.
Okay.
So by mid-2027. And Ilya Sutskever, the co-founder and chief scientist of OpenAI, is joining the team. He's co-leading it with me. And OpenAI is committing 20% of the compute secured so far to this effort, or to the effort of aligning superintelligence. And so we're staffing up the effort a lot. We are hiring a lot of people. In particular, we're interested in hiring machine learning researchers and engineers who haven't really worked that much on alignment before. And because we think there's a lot of scope for them to contribute and have a really big impact. And we have a general kind of overall plan of how we want to approach the problem that involves training a roughly human level alignment researcher that can work automatically, and then ask that automated alignment researcher to figure out how to align superintelligence.
Okay.
And so one of the key pieces for us to do would be to figure out how to align this automated alignment researcher.
Okay. Yeah, so I'd actually like to get into this. So I think in the blog post you use the phrase human-level automated alignment researcher, right? What should I imagine here? Like what is that?
Yeah, so basically we want to offload as many of the tasks that we do when, we're doing alignment work to an automated system.
Okay.
And so typically when you using LLM, or if you're building an AI system in general, the skill profiles they have isn't exactly what a human would do, right? They would be vastly better at some things, like language models are now on translation or knowing facts and so on. And then they're the AI system would be significantly worse in some other tasks, like language models are right now with, for example, arithmetic. And so the question then becomes what are the kind of tasks that we can offload to the AI systems, in which order. And, as we're doing this, you'd expect humans would focus more and more on the tasks that we're not offloading. And so as we kind of go into that process, right, AI systems are doing a larger and larger chunk of the overall work, and human researchers will basically thus be more and more effective at actually making progress.
Okay. So should I imagine something instead of you replace the first OpenAI alignment team employee and then the second one, you should imagine you replace this type of task that everyone is doing and then this type of task that everyone is doing, roughly that kind of thing?
Yeah, that's how I picture it going. And then I think in order to actually get a lot of work out of the system, right, you'd want to have 99 or 99.9% of the tasks being automated, because then you have effectively 10x, 100x, 1000x as much research output.
Okay. What kinds of tasks are you imagining it doing?
Yeah, so broadly I would throw them into two different buckets. One bucket is kind of the tasks that look more like just traditional ML engineering research that you would do if you're just trying to make AI systems be more capable.
Okay.
And then the other bucket is, all the other things that we have to do on alignment. And so, in the first bucket, this is stuff you're running, implementing ML experiments and running them and looking at the results. And the second bucket, it's more how do you, for example, figure out what experiments you should run on to improve scalable oversight, or how do you make progress interpretability, right? These are let's big high level questions.
Okay.
But there's also just a lot more detailed questions of you have a given point that you are in research, right? Let's say you have just written a paper and you're okay, what do we do next if we continue down this route? And so I expect that basically, ML in general will get really good at the first bucket of just, designing, running experiments automatically.
Mm.
And kind of our job of differentially accelerating, alignment progress would be to figure out how to automate the second bucket.
Okay. And so you're conceiving of the second bucket as like the full stack from like coming up with research directions to like coming up with like ideas of what things might work to like all the way down to like what script do I run right now?
Yeah. I mean, you could ask me, like if I think that alignment research is like so similar to machine learning research, like how much is that really in the second bucket? But I think there's actually a lot in there, and it's highly leveraged because kind of like alignment as a problem is still so vague and confusing. And like I think in general, there's a lot of disagreement among experts where like the most promising directions or like what should we do next. And so the more you can accelerate what we do there, it will actually have a really large impact.
Okay, cool.
This is basically the same pitch that you would give for like, a researcher to join the field, right? It's
yeah.
We're still trying to figure out the basics. It's a wide open research problem. We don't know how to align superintelligence or even, like systems that are significantly smarter than humans. So
makes sense. So yeah, it's like we want to recruit AI. It's just like we want to recruit more people, I guess.
That's right.
All right.
But there's something really beautiful about recruiting AI, which is it scales so much better and faster than humans do, because all you need to do is buy more GPUs and then you have more AI.
Makes sense. So one question I had is like when you said a human level alignment researcher, like it seems like often in AI, it's like most things aren't exactly human level at anything, right? So like you mentioned, like chat models, I think they're like superhuman and just in terms of breadth of knowledge, right? I think it would be hard for anyone to know as many facts as like GPT-4 does, but subhuman at arithmetic, at least if the human's allowed to have like pen and paper, So how important is the human level qualifier? Like if on these like lists of tasks, if it's like really superhuman at some of them, is that like a problem for you, or is that just so much the better?
Yeah, I think the question is really like how risky is it to run that system on the task of alignment research, right? Because, if it knows a lot of facts, that isn't particularly scary. But what we really need to figure out is like if we let the system take over some amount or ultimately like almost all of our alignment research, will it like, lie to us? Will it try to deceive us? Will it try to take the opportunity to take over? Because now it's doing so much stuff that we can't all look at ourselves. And so the question is like, the kind of skill set that you would need to do this, how does it compare to the kind of skill set that we would need to get like a lot of assistance in alignment research? And if you zoom into that question, right, like what are like other actually the things that we would be worried about? This is like, how good is the model as like spinning really coherent lies or like being deceptive of like pretending to do something or believe one thing and then actually wanting another. I think another like really key capability here is self-exfiltration. So how good would the model be at like breaking the security precautions and like accessing its own weights and trying to copy it somewhere else on the internet, or persuading an engineer with access to the weights to, like download them and send them somewhere. And so we can like specifically measure how good the models are at that. And then we can compare it to measuring it like how good is it at like actually helping us with alignment research.
Okay. And so roughly the idea is you want the models to not be too good at these like scary tasks.
That's right.
Yeah. So this actually like relates to a critique of this line of research that basically says like, okay, if I want like a human level automated alignment researcher, it needs to be pretty smart. It needs to be creative, right? It needs to like think of things that like we haven't thought of yet. It needs to like be able to sort of plan towards a goal, right? Like I want to get this, so I've got to like do these non-obvious things in the way. I've got to like, learn things about the world. And it's also got to be like really good at thinking about misalignment, right? Like in order to solve misalignment problems. And so one might think like, oh, that combination of things, that's like inherently scary or dangerous. And I guess the question almost is then, well, if you have that, like if the task is like you're building something, you're aligning this like automated alignment researcher, do you even have any problems left, right? for it to solve.
Yeah. Yeah, I think ultimately this is an empirical question, right? Like it's kind of really difficult to know in which order, like which skills get unlocked when you scale up the models, and like there's a lot more work aimed at like predicting emerging capabilities now, and I'm really excited about that, and I think will give us some chance of like actually predicting what the next pre-trained model will be like. But I think also, I mean, I think we can make some high-level arguments. So for example, like one thing that is pretty clear is like once you have the model as good as you can hand a lot of alignment research off to, wouldn't it then also be like able to just like improve its own capabilities? Or like, it can do a bunch of ML research, so you can run like experiments on like improving language models compute efficiency or something. And then you could like, use that and like pre-train a much more capable model shortly thereafter. And I think the story like sounds on the surface appealing, but I think in practice it'll be actually a lot more complicated because you're not doing big pre-trained runs like every week. Like they usually take a few months, and so it would be a few months before you actually have that. And in the meantime, you still get to use the system. I think the other thing is also like there's kind of an open question of like how much low-hanging fruit there still is on actually having compute efficiency wins. And I think ultimately the argument here I would make is that like right now, the existing community of people who are like trying really hard to get like AI to go faster and be more capable is already quite large relative to the alignment community. And so if you get to kind of like automate a lot of these tasks and both communities like benefit equally, then I think actually like alignment benefits a lot more because it's a smaller community. And so we don't have to do these tasks anymore.
Sure. I guess my question is like, given so I took the plan to be something like we're going to make this automated alignment researcher, and then it's going to help us with alignment. And given that like in order to make an automated alignment researcher, like it needs like quite a lot of like pretty smart, pretty good capabilities. Like what problems does it need to solve that we wouldn't have needed to solve in order to get it?
I'm not sure I understand your question. Maybe I can answer like the second part of the previous question that you asked, which is like, what about long run goals? What about creativity? It seems like, to me at least, that language models or like AI in general has proven to be like on average more creative than humans, I would say, right? Like if you look at like, I don't know, the diffusion model images, or if you look at like, you sample from a pre-trained base model or something, there's a lot of really wild stuff in there. And there's a lot of creativity that I think you would really struggle to get out of a single human or a small group of humans, just because, the model has seen like the whole range of like everything humans have said, or like all the images on the internet. And so they can sample actually from the whole distribution, whereas like individuals, humans typically can't. And then in terms of long run goals, I think this is actually not needed at all because, we can hand off like pretty small, well-scoped tasks to AI systems that if they really nail those, it would actually be really useful, right? And that could be like really small range things like, here's like the paper that we just wrote, please suggest like some next steps or like some new experiments to do. And like, if you imagine having like a really A-star researcher that you can ask these questions, they don't have to like pursue long run goals, right? They only have to optimize over the next like, I don't know, a few thousand tokens. And if they do that super well, then you would get a lot of value out of them.
I guess. That seems like it's in tension with this aim to like automate 99.9% of alignment research, right? Because like I would kind of think that like thinking, what things do we need in order to get an aligned AI? I would think that's like a significant chunk of the difficulty of doing alignment research.
That's right. But I think, so what I wanted to say is like, the system's adding a lot of value by like really excelling in these tasks, right? And then what you do is like you have a whole portfolio of these tasks, right? Like some tasks will be like, write the code that implements these experiments. And then like there's another task that is like, look at the results and tell me what you see, or like suggest what to do next. And now, once you have done these tasks, you compose them using some like general recipe. Like as people do with like AutoGPT or like language model programs, where like each of the tasks is like small and self-contained, and so the system doesn't need to pursue long-run goals. Or, for example, the recent work that came out from OpenAI on the using process-based feedback on math, where instead of training on did the system get the right solution and just doing it all on that, you kind of like train a reward model from human feedback on every like step in the proof.
Yep.
And it turns out that's actually much more effective because it kind of gives like the AI system a much more fine-grained way to learn and like more detailed feedback. Now, is that going to be competitive with like, did you do end-to-end RL on like, did you get the solution right in the long run? That is very unclear. But at the very least, you can use this kind of broken down, like, step-by-step setup, get the system to do a lot of really useful things that humans would have done, and then piece it together.
Yeah. Although even the small tasks, so like one of the small tasks you mentioned was like look at results and decide what to do next. I guess I would have thought that like in order to do that, you kind of have to have the big picture in mind and think like, well, what next project is like most useful for my goal of like solving superalignment in 4 years, right?
That's right, but you wouldn't do this in the sense that you're like trying to optimize and do credit assignment for 4 years. It's probably more like, well, you're just adding some like broader goals and context like into your prompt. But like when you're actually like doing reinforcement learning or like reinforcement learning from human feedback to improve the system, then you don't have to wait until like, that research project concludes to decide whether or not it's good or not. It's just like, you use the human as like a reward shaping. You're just like, does this look like a good direction that seems better than any directions I could have thought of or something? And so I think the overall goal here is not to like build the most capable automated alignment researcher that we possibly could with the tech that we have, and rather build something that is really, really useful, that we can scale up a lot, and most importantly, that we trust is aligned enough to hand off these tasks to. And so if we introduce like a fair amount of inefficiencies in this process, right, like where we're essentially like sandbagging the model capabilities a whole bunch by training it this way, and we're like, well, we giving it these broken down tasks, and now it would execute those, but if we train it end to end, it would be more capable or something. I don't think that matters as much. So this is typically what like people call the alignment tax. And the alignment tax matters a lot if you're like, let's say, competing in the market with other companies. Like I'm building like a chatbot or something, and my chatbot is just, it's more aligned, but it seems a lot less capable. That would have a hard time competing in the market. But if you have an automated alignment researcher, the automated alignment researcher doesn't have to compete in the market. It just has to be useful to us. And so we can get away with paying a higher tax because we just don't have a replacement. Okay. Or like the real replacement is like, hiring more humans, which doesn't scale that well.
Okay. I guess another way to ask the question I was going to ask previously is like, what problems will you want this automated alignment researcher to solve?
I mean, ultimately, it should solve the problem of how do we align superintelligence.
Okay. So it's the idea that like we solve the problems of how to align something roughly human level, and then there's like additional problems as it gets smarter and like it just starts taking on those?
Yeah, basically. So I imagine that an actual like, solution to aligning superintelligence that we and lots of other people actually truly believe in will look quite different from what we do today, right? If you look at how ChatGPT is aligned today, it's like a lot of reinforcement learning from human feedback, and there's a widely shared belief that I share that just won't scale because it fundamentally assumes that humans really understand what the system is doing in detail.
Yep.
And if the system is doing a lot of alignment research at like, where you're thinking of like millions of virtual human equivalents or something, there's no way you'll be able to look at all of it and like give detailed feedback. And it's a really difficult task, and you'll miss lots of important bugs. But the kind of techniques we're looking at right now to kind of like scale this and like align a roughly human level alignment researcher that can do these difficult tasks, but won't do it like, crazily differently that, humans would, are like kind of like steps or continuations of that, right? Like scalable oversight, for example, is a natural continuation of reinforcement learning from human feedback. Or
what is that?
A scalable oversight?
Yep.
So scalable oversight, I would define as like generally a portfolio of ideas and techniques that allow us to leverage AI to assist human evaluation on difficult tasks.
Okay. So scalable oversight is an example of a thing that you could build off of reinforcement learning from human feedback, often called RLHF.
Yeah, and so like typical examples of scalable oversight are like debate, recursive reward modeling, iterated distillation amplification, like automated market making, and so on. And there's like a bunch of ideas floating around. But what I actually wanted to say, to get back to your original question, is like, I think if we actually aligning superintelligence, which is, like this system that is like vastly smarter than humans, can think a lot faster and like run at a much larger scale, that just like introduces a whole lot of other problems, especially because it will be super general, it can do lots of tasks, and then you have to figure out how to align it, not just on the like much more narrow distribution of like alignment researchy tasks, but everything else. And also, you want to have a much higher degree of confidence that you've actually succeeded than you would get with, like, let's say, a bunch of empirical evaluations. And so I don't really know what that would look like, and I don't think anyone does, but I think it would be really exciting if we can have some formal verification in there. Maybe, like, we figured out, like, some kind of learning algorithms that has theoretical guarantees. Like, I don't know what even would be possible here and theoretically feasible if you have, a lot of cognitive labor that you can throw at the problem.
Okay.
But all of these things are like very different from like the kind of things that we would do right now or like that we would do next. And I also don't think that like roughly human level alignment researcher would like start working on those problems right away. And instead what they would want to do is we would want them to figure out how to better align the next iteration of itself that then can like, work on this problem like with even more brain power and then like make more progress and like tackle a wider range of approaches. And so you kind of bootstrap your way up to eventually having a system that can do very different research that will then allow us to align superintelligence.
Gotcha. So once you have these like human level AI alignment researchers like running around, like, do you still have a job? Like does OpenAI still have a human super alignment team?
Yeah, good question. I mean, I would be excited to be replaced by AI, to be honest. But historically what typically happens is like, what we mentioned earlier is like the AI system does 99% or 99.9%, and then we just do the rest of the work. And like, I think also something I'm really bullish on is like making sure that humans kind of stay in the loop or like stay like in control over what AI systems are actually doing, like even in the long run when, we're kind of long past really being able to understand everything they're doing. And so there'll be like some humans that still have to like try to understand what the high level is of what AI is trying to do. So that wouldn't necessarily have to be like the super alignment team that is at OpenAI now. It might also require a very different skill set that we have right now. But I think ultimately humans should always stay in the loop somehow.
Okay. Gotcha. So yeah, actually, speaking of, I guess the loop, wow, that's a bad segue, but I'm going with it. So one thing that that OpenAI has mentioned in a few blog posts is like, so firstly, there's this idea that like safety is like actually pretty linked to capabilities. Like you need smart models to figure out the problems of alignment. Another thing is that there's this desire to avoid fast takeoff, right? And I think there's this quote from Planning for AGI and Beyond that says, it's possible that AGI capable enough to accelerate its own progress could cause major changes to happen surprisingly quickly. And then it says, we think a slower takeoff is easier to make safe. So one thing I wonder is like, if we make this like really smart, or human level alignment researcher that we then like effectively 10x or 100x or something the size of the alignment team, does that end up playing into this like recursive self-improvement loop?
I mean, it really has to, right? Like, you can't have a recursive self-improvement loop without also improving your alignment a lot.
Okay.
I personally think fast takeoff is reasonably likely, and we should definitely like be prepared for it to happen. And if it doesn't happen, that's, I'm happy about that. But
how fast are we talking?
I mean, ultimately, I don't know. But like, if you can draw some parallels to some other machine learning projects like AlphaGo or Dota or StarCraft, where the system like really improved a lot week over week. I think, yeah, there's obviously a lot of uncertainty over like what exactly happens, but I think we should definitely like plan for that possibility.
Okay.
And then and if that does happen, right, like a really good way to like try to keep up with it is like to have your automated alignment researchers that can actually like, do thousands of years of equivalent work within like every week. And that's just no way that that's going to happen with humans.
Okay. Now that we have a better sense of what you mean by like what we're looking at with an human level automated alignment researcher, can you give a sense of what the plan is to make one?
Yeah. So, you basically need two parts. One is you need a system that is smart enough to do it. And then the second part is you need to align it to actually do it. And I think they're not two separate parts. I think they're very intimately linked. And I'm personally not working on the first one. I think that will definitely happen. And a lot of people are working hard of making it happen. And, there's a lot of different ways that could go, but you could just picture like pre-training a much larger model and eventually it will just be smart enough. And on the second part, that's the part I'm really interested in. And so the question is like, now you have this like really smart pre-trained model. How do you get it to actually do alignment research in the way that, you would want it to? Or like more importantly or more critically, how do you know whether you can trust enough to do that? Because if you're handing this kind of tasks off to AI, there's this opportunity that like a smart AI system could just like try to figure out how to present results and techniques to you in a way that if you then decide to implement them would actually empower the system itself or like some, other related system and give it more opportunity to have more power-seeking behavior in the future. Or let's say self-exfiltrate, for example.
Yep.
And so what we need to do is actually align it to do the task and leverage its capabilities to do it basically as well as it could. So that is the what I would call we need a bunch of alignment training methods. And then we also need to be able to distinguish a model that is actually aligned on the task and tries to do alignment research really well and actually help us and be honest and be truth-seeking, and a system that pretends to be that to us but actually wants to take over the world or say self-exfiltrate or do something else. And these are two different systems. One is basically the truly aligned ones, and one is the deceptively misaligned one. And an important part of our job is figure out how to distinguish these two systems.
Okay.
And that will require a bunch of methods that I would call validation methods. So these are methods that we wouldn't really train on in the sense that the AI systems wouldn't be directly selected on passing the validation tests.
Yep.
And more, they will give us some kind of independent signal of, which of one of these two versions is it.
Okay.
And so examples here are, interpretability research, for example. If I can look inside the model and find some evidence that it's secretly plotting against us, that will then not fail. That will fail the validation test, right? Another technique that could either be training or validation, depending on how it's set up, is this easy to hard generalization problem. Can you understand and improve the model's ability to generalize from easy problems that we can supervise to harder problems that we struggle to supervise? And if you can do that, now you can just like, you supervise the model on the easy parts, and then you're like cross-check, like, on the difficult ones where you'd worry that the model might secretly deceive you or like try to do something else.
Okay. Cool. So yeah, there's a few things there. I guess I'd like to talk about the scalable oversight part first. Yeah, how are we going to do this? Especially like as background, I think we live in a world where like there's not a lot of consensus on what like good alignment research is. So yeah, how are we gonna like get a training signal for what counts as good alignment research?
Yeah, exactly. And I think that's like the reason that there isn't a consensus is like good evidence that the problem is actually hard, but also it tells us that, well, the field is still immature and like we haven't gotten that much empirical evidence so far. But I think there is some really important property that alignment research has that we can leverage for scalable oversight, which is that I think it's fundamentally easier to evaluate alignment research than it is to do it.
Yep.
And doesn't mean it's like, easy to evaluate, but it is much easier to find, for example, a paper that does some like has a cool idea and does some cool experiments and gets some good results, and you read that and you're like, oh, actually, this is a really good idea. I think this is good. Then it would be to produce that work in the first place. And so leveraging this principle that evaluation is easier than generation is kind of like core of a lot of scalable oversight ideas. And so, for example, if you're thinking about like recursive reward modeling, where the basic idea is you have some kind of like AI system that you use as an assistant to help you evaluate some other AI system. So now, because evaluation is easier than generation, like the task that the assistant has to do is like a simpler task, especially like, because you're working together with it. So actually aligning the assistant on the simpler task of like the evaluation assistant, or like, let's say the claim is that would be easier.
Okay.
And like, if you succeeded that task, then now you use your human assistant conjunction to supervise a new system on an even harder task. And so if you keep doing that, you're like unlocking a more broader and broader scope of tasks that you can like effectively supervise your AI systems on.
So somehow the idea is that like we're iteratively adding like more and more AI knowledge to like basically to the evaluation portion of AI alignment research. And like by doing it this iterative way, like the idea is that we can like consistently give it a like good training signal.
Yep.
Okay.
Let me make this a little bit more concrete. So for example, our OLHF is kind of like, the simplest one where you don't use any assistant, right? Like your AI system does something, a human looks at it and says whether it's good. Yep. And that's your training signal. And now like the next step up from that is basically you train the simplest assistant model, which is just a critique model.
Yep.
And so you have a separate language model that looks at what the first AI system did, and then it writes critique. And so let's say the first AI system is writes some piece of code, and you look at the code and like, humans are notoriously bad at finding bugs in code. That's why there's so much buggy code out there in the world. But now if you have a critique system that like writes a critique and it points out the bug, it's so much easier for the human to say, oh yeah, this is totally a bug. We should fix that.
Yeah.
And it's also not, a super crisp task necessarily, because usually the code is written for some kind of natural language specification. And so what is actually meant by that is somewhat vague, and like what actually, whether something is a bug is like, can be ambiguous. But the important point here is that like, you kind of, because you're using the critique model as an assistant, and if the critique model, now you can supervise a wider range of tasks, because essentially you can like find all the problems in code that your AI system would find, or like where it would have written a critique, which might not be exactly the same as like all the code where it knows there's a bug in there.
Okay.
But you have expanded the like range of things that you can supervise.
Yeah.
So the really nice thing is that I think actually there is like there's a bunch of ways in which we can actually empirical measure how well this works. And so there's like one way, which is kind of what we did in the critiques paper that we published last year, where you basically do randomized controlled trials with targeted perturbations. So you take some kind of, let's say, a coding task. In the paper, we didn't do a coding task, but the task doesn't matter here. And then you have a response. The response doesn't even have to be perfect, but let's just assume it is. So what you do is you introduce some kind of subtle bug in there, some kind of subtle flaw that would make it like, a bad response, but it's you want it to be hard to find for humans.
How do you introduce this bug?
So the simplest thing is just you like ask humans to do it.
Okay.
But ultimately you want to do it with the model, and I'll get back to that.
Okay.
And now you have this like paired response, right? Like you have the original response and you have the response that is worse because you made it worse.
Yep.
And now you draw one of them at random and you show it to like a human, or like a human assisted with AI, or like whatever your scalable oversight method is.
Yep.
And then you see like how likely are they to find it, or like you just ask them like, is there a bug here? And now you can measure like if you have a better way to assist them, you can see how often they find the bug. But you can do even more, which is you can directly compare this to how much does the model know that there's a problem here by training it essentially to be a discriminator between the good version and the flawed version. And if you look at the accuracy for that, that's like the discriminatory performance. And then you like check that with like if you ask the model, or like at the RLHF version of the model, to write a critique of the code, how often does it actually like write about the flaw? Now you get like this critique accuracy equivalent.
Yep.
And now you can compare these two numbers. And that's what we call the discriminator critique gap.
Okay.
And if you have a large discriminator critique gap, that means that there would be like a lot of problems that the model like kind of can smell or like knows about, or like whatever metaphor you want to use. But it's not telling us, because if we ask it to write a critique, it doesn't say it.
Yep.
And a large discriminator critique gap would be very worrying, because it means that your scalable oversight is like somehow very flawed, and there's a lot of things that slip your radar. Or the assistant is in a sense like not very aligned, because it's not trying very hard to help you. And if the discriminator critique gap is pretty small, that is somewhat reassuring, because it means like, if the model knew there was a problem there, it would tell you. And so in particular, if like a similar sized model, or like the same base model, was like trying to plant a problem, or it's like it was trying to like, let's say, put Trojans in your code that is hard for you to find, but if you did run the code, the Trojans might fire, and then it could like take over or do something else. Then presumably it would know that these kind of Trojan could be there because it planted it itself, right? And so if we have this other copy of the model, then it would like, if we measure a small discriminator critique gap, we'd have more confidence that this can't be the case, because the other copy of the model would presumably then write a critique.
Yeah.
And this kind of hinges on the assumption that like discriminator training actually like can take out of the model like this kind of thing. And I think there's good reason to believe that, because if you're fine-tuning for a discriminator, you have like a way to access all of the activations that are everywhere in the model, because you can fine-tune all of the weights simultaneously. And so if the knowledge is somewhere in the model, in its model's activations, then a discriminator fine-tuning, on like, if you do it right and you have enough data, it should like be able to extract it. And in fact, like you can like give some like back of the envelope calculations of like how much data you would need. And like, if you want to identify like one neuron that like, this is not how it works, but like hypothetically, if there was one single neuron that knew the code is bad, you would need like log number of total neurons data points to like narrow down and find it, which is not that many.
Yeah, so I guess this actually gets to a question I have about the whole scheme. So the reason we didn't like RLHF, right, is that there's this concern that it wasn't going to distinguish between things that were right and things that sounded good to the human.
Yep.
Because the human was like bad at critiquing. And with this like recursive critique thing, with like training a discriminator and then a critiquer, I wonder if we still have that fixed point, right? So like one world is like, we have a thing, we train it to like write actually like good critiques, and then we join ourselves with it to like train a thing that writes even better critiques, right? But I worry like maybe there's another fixed point where we train a thing and we accidentally train it to like write pseudo critiques that sound good to us, and we join with it, and then we're even better. It's like looking critiques that sound good to us, and then we train this discriminator to discriminate between like things that don't have problems and things that seem like problems to us. So I'm wondering, like, yeah, how worried should we be about like things that seem good to us rather than like things that are actually problems being a fixed point here?
Yeah, I think that's a really important valid concern to have. And in a way, that's like one of the key things we need to figure out about scalable oversight, right? And so this is the reason why I'm excited to like actually implement these techniques and try them out empirically. And because I think we will just be able to measure how much this effect shows up in practice. And like one concrete, like simple way we can measure it is like we actually just deliberately train a deceptively aligned model, and then we see if the scalable oversight flags it, or like, how hard is it to, or like how much effort do we have to put into making the model deceptively aligned such that it would pass our scalable oversight.
Yeah, I guess there's also these like sandwiching experiments, right? Where you have an AI that's like trying to answer legal questions to some people who don't know much law. And then like you get some people who are like really good at law, and hopefully like they can check if like the AI has fooled the people.
Yeah, I think these experiments are interesting, and there's some interesting work on this already. I think there is some fundamental problems to this setup. One is you really have to trust your experts, and the experts are going to be wrong sometimes. And then you have to have like sufficient domain overlap. Like we did a little bit of preliminary experiments with this where we had like non-coders who were supposed to use assistants to figure out problems in code, and they didn't even know how to ask the right questions. And so you have to have like, some overlap. And then the other problem is also that I think the tasks that I'm fundamentally really interested in, we just don't have ground truth on. And like, even if we like, let's say alignment research, we're doing alignment research, now you can be like, oh, we'll just get some alignment researchers to label some tasks.
Yeah.
And then I'd be like, well, what if they are wrong? Like, we don't agree about so many things. Like, that seems hard. And then also like, there's not that many and their time is very expensive. So that would be extremely expensive data. And so in general, I would want to have an evaluation method that doesn't rely on the assumption that we have ground truth.
Okay.
And this is why, like, I'm excited about the prospect of using these like randomized control trials with targeted perturbations, or like the measuring the discriminator critique gap, because you can do this even if you don't have any ground truth, and the task can be arbitrarily hard.
Yeah. Although even in those, like measuring the discriminator critique gap, it's still got to be the case that you're like, that you have an actual discriminator versus a discriminator of like things that seem like problems versus things that don't seem like problems, right?
I mean, you can have AI systems introduce the flaws, right? And in a way that is also much better than humans doing it, because it'll be more on distribution for actual like what AI systems would do. And if you're fine-tuning your discriminator on that data, you actually do have ground truth if you can trust that the flawed version is actually worse.
Yeah, and I guess
the way you could trust that is like, well, you like look at the reason why it's worse, and you can verify that reason, which is a lot easier.
Yeah, I guess there's some hope that like even if the AI can make you think things are good that aren't actually good, maybe if the AI makes you think something's bad, it is actually bad, or like that it's degraded the performance. That if the AI makes you think it's degraded performance, maybe it's easier to check that it's degraded performance.
Yeah, I mean, I see your point. Like, I probably shouldn't actually use the word ground truth in that setting, because it is not like truly ground truth, just as like nothing really is truly ground truth. But there's like a variety of things that you can do to like make you very confident in that, in a way that doesn't necessarily make the task of finding the problem easier.
Okay, gotcha. I think I want to talk a little bit about the next stage of the plan. So searching for bad behavior and bad internals, I think was how it was put in the Superalignment post. What sort of open problems do you see here that you'd want the Superalignment team to be able to solve?
Yeah, so I mean, the kind of like obvious candidate here is interpretability, right? Like, in a way, like interpretability is really hard. And like, I think right now we don't really have any slam dunk results on language models where we could say like, interpretability has really like given us a lot of insight or like added a lot of value. And this is because we're still pretty early in like understanding the models and what's going on inside.
So there are some results. Some people do some interpretability things to language models, right? So like there's this induction heads work. There's this indirect object identification work or for a circuit that does at least a certain type of indirect object identification. I'm wondering like what would you need beyond those to get what you would consider a slam dunk?
Yeah, I don't mean to diminish like existing work here. And like I think
you can
there's
score
a lot of...
in basketball without getting a slam dunk, right?
Yeah, and like I think they're, like very cool things have happened, but I think something that I would like consider like a really cool result is like, you use your interpretability techniques on a language model or word model, like a GPT-4 size or like whatever your like largest model is. And then you say something about the reward model that we didn't know before.
Yeah.
And like that would be really cool because the reward model is what provides the training signal for like a lot of the RLHF training. And so understanding it better is super valuable. And like if you can flag or find problems of like behavior that it incentivizes that you wouldn't want, that would be really cool. I think that is doable. And like I think importantly, in that sense, like I think interpretability is like neither necessary nor sufficient. Like I think there is a good chance that we could solve alignment purely behaviorally without actually understanding the models internally. And I think also it's not sufficient where like if you solved interpretability, I don't like really have a good story of how that would like solve superintelligence alignment. But I also think that any amount of non-trivial insight we can gain from interpretability will be super useful or could potentially be super useful because it gives us like that avenue of attack. And if you kind of think about it, I think it's actually crazy not to try to do interpretability because in a way you have this artificial brain and we have the actually perfect brain scanner, right? Like we can zoom in completely and like fully accurately measure the activation of every single neuron like on each forward pass, so like on arbitrary like the discrete time steps. So that's like the maximal resolution that you could possibly want to get. And we can like also make arbitrary interventions, right? We can like perturb any value in the model like arbitrarily how we want. And so that gives us like so much scope and opportunity to like really do experiments and like look at what's happening that would be crazy not to leverage. But at the same time, like the reason why it's very hard is because the model is like learning how to do computations in like tailored to our efficiency, and it's like not regularized to be human understandable or like there's no reason to believe that individual neurons should correspond to concepts or anything near what we humans think they are. Or it should be, or like what are familiar to us. And like in fact empirically, right, like neural networks represent many different concepts with like single neurons, and every concept is like distributed across different neurons. So like the neurons isn't really what like matters here. But one path I think there's like two things on interpretability that I'm super excited about. Like one is like the kind of like causal version of it, right? Like you want to not only like look at a neuron as you're passing data through the model and say like, oh, this fires when, we have stories about Canada or something. This is like one of the things that we found in the interpretability paper. We had like this Canada neuron that would like fire at Canada-related concepts. But it's only correlationally, right? Like you observe a correlation between Canada-related concepts and that neuron firing. But it's not a causal relationship. In order to check that it's a causal relationship, you have to like deliberately like write text that has Canada-related concepts, see if they all fire, but also put in like other related concepts that maybe sound like they could have something to do with Canada or like don't have anything to do with Canada but are like similar, and then check that the neuron doesn't fire. or you like take a text and then edit it and check that the neuron turns off and things like that.
Yeah. I guess this is reminiscent of this, I think it was called the interpretability illusions paper, where they noticed like on Wikipedia, you can have neurons that fire on one specific thing, but then on other data sets, it's just like, that was just an illusion. It fires on a bunch of other stuff.
Yeah, and like I think the other thing that is really exciting is like, the work that we've kind of started last year, where we released a paper like earlier this year on automated interpretability. And here the idea is like, basically what you'd want is like, you would want to have a technique that both can like work at the level of detail of individual neurons so that you can like really make sure you don't miss any of the details, but also can work at the scale of the entire model. Because at the end of the day, like, everything kind of works together and everything is like highly connected in the model. And so you kind of need both. And so far, techniques have kind of mostly worked on one or the other. Like there has been like attempts at like, there's been work on automated interpretability before our paper. So it's not like we were the first ones. But I think in general, if you can have some kind of like really detail-oriented interpretability work, like some kind of mechanistic interpretability approach that really tries to understand individual circuits or like, computation units inside the model, the way to then scale that to the entire model is you need automation, right?
Yep.
But you can do that. Once you figured out how to do it on the detail, then you just record what you're doing. Like,
yeah.
I mean, I'm like, simplifying a bit too much here, but like I think that's the general like scope that I would be excited about. Also because it really fits with our automated alignment goals, right? Like we want to have our automated alignment or interpretability researcher to like really look in detail into the model, understand what's going on, then like we sift through the whole kind of everything, or like we find ways to aggregate it. And so for the paper, we had like a dump of like explanations. So the paper does like it writes like natural language explanation for individual neurons, which is kind of like not quite the right thing to interpret as I mentioned previously, but it gives you like a simple example of like what we could do here. And the way it works is like you just show a bunch of like activations patterns to GPT-4 and you have GPT-4 write a proposed explanation. And in general, these explanations aren't very good, also because the task is so hard and it's like, most neurons don't do like a very clearly human understandable thing. But we can just run this on the scale of like every neuron in GPT-2 and then just like dump all the explanations and then like try to find what is like interesting patterns. And you can like look at scaling trends and be like, how does the automating scoring of these explanations like scale as models get larger, or like what if we add more compute or we like make the model as doing the interpretation bigger, like how does the quality of explanations change? And like the really cool thing is that we can just measure this automatically again using language models, and it's not a perfect metric and like there's a bunch of problems with it, but it gives you a proxy for like what would a human think this explanation is good. And then you use this proxy at scale and just like run it on like a ton of neurons.
Yeah. So if you think about the necessary interpretability work, do you think how much of it do you think is just like figuring out a better fundamental unit of interpretation versus figuring out like how to scale what's happening or other things you might?
I mean, I think it needs to be both. Like, I think it's very reasonable to believe that the former is much harder, but I think the scaling part is needed for it to succeed.
Gotcha. Yeah, so I guess part 3 of the plan was something like deliberately training misaligned models and seeing if the pipeline could detect those. And yeah, are you planning to like weed them out or like actively fix them?
I mean, the goal here would not be to like fix a deliberately trained misaligned model.
Okay, just to detect.
Yeah, so fundamentally, like one core aspect of what we need to do here is we need to be able to distinguish between like the actual aligned alignment researcher that does what we want and that truly wants to help us make progress on alignment, and the one that, like pretends to do that, but secretly wants to take over and self-exfiltrate. And one way we can figure out more about how good we are distinguishing these two is we make the second one and see if it looks like the first one to us.
Okay.
Obviously, that's you have to be very careful with doing that because you're kind of making the scary thing that we're all trying to avoid, right?
Yeah, I actually wanted to ask about that. So I think at the start of the post, so there's one sentence about how great superintelligence could be, and then it says, I think, that it could lead to the disempowerment of humanity or even human extinction. So, what are we talking about with misaligned models? How do we know they're not going to do those kind of awful things?
Yeah, so, let me put it this way, right? There's a lot of things that are needed to make the future go well. Right, we need to have the right governance structures so that we can prevent misuse of powerful AI systems. And we have to have precautions so we don't run into some kind of emergent runaway effects that are still bad for humans, where you have aligned AI, but AI is aligned with corporations who are not aligned with humans or something. And then the whole system goes off the rails, but it looks good at all the economic metrics or something. And also, we need to solve technical alignment so we can actually align AI systems. And so the risks that, what superalignment is looking at is just the last part, right?
Okay.
We want to figure out how the technical problem of how to align, one AI system to one set of, human values. And there's a separate question of what should those values be, and how do we design a process to import them from society. And I think these are really important questions, and we really have to answer them too for the future to go well. And I think for the future to go well, the bar is not AI doesn't kill literally everyone, but I want there to be lots and lots of human flourishing, and I want to have a future that everyone is really excited to live in. And the more powerful AI gets, the higher the stakes will be, right? Because there'll be more risk from misuse, and there'll be if systems are misaligned, they'll things can go wrong a lot more. In particular, the threat models that I think we should particularly worried about from a misalignment perspective is kind of systematic lies and deception and self-exfiltration.
Okay. When you say when you're deliberately training misaligned models, is the idea that you would train them to lie and potentially self-exfiltrate, but at a low enough capability level that it's fine or something?
You wouldn't want to train the model actually to self-exfiltrate because, what if it actually gets good at that, right?
Okay.
You would want to pick some kind of other proxy task that is a lot more mundane, but that still tells you that, it makes it easy to evaluate whether or not the model is succeeding at it. And then, the core difficulty and the core goal is really figure out how hard it would be for a system that has to have the kind of properties that it would need to still pass the evals, right? If you have a system that is lying to you or deceiving you, that's kind of really ineffective if it only does so sometimes. And then if you ask it, oh, did you lie about this? It says yes. It wouldn't be a very coherent, believable liar. The scary systems are the really coherent and believable liars that lie super consistently, where it would just be really hard to interrogate in a way that points out its lies or any sort of inconsistencies in what it's saying. And I think actually to be this kind of consistent liar is not that easy. And our whole goal with what we're trying to do with scalable oversight and interpretability and generalization is that we want to make it really, really hard for the model to be this consistent liar.
Okay.
But if we just do that, right, we don't know how hard it actually is. And one way we can find out is we train the model to be a really consistent liar. And then we see how hard it is. How much do we have to cheat? How much do we have to like give the model hints or like handhold it along the way. But without like, you don't actually want to like train a dangerous system that like, if you did run it, it would like successfully self-exfiltrate, because then you've like caused the very thing that you're trying to prevent. And that would be like, that'd be really bad.
So when you say that, are you distinguishing like lying from like other kinds of danger, such that we could train it on lying, but like we're not going to train it on like murder, for instance?
Yeah. So let me try to give you an example. So let's say you're giving it some kind of fake goal. Maybe it is like to persuade the human to like say a certain catchphrase, or like maybe it is to like run a certain Python command that in fact doesn't do anything, but it looks interesting or something.
Yeah.
And you can very well, it's like so easy to measure whether the system succeeds, and you can set up the experiment so that it's hard to do that a priori. And like if you're, let's say, and like the goal here is not to like have the system like stress test, like let's say our like cybersecurity or something. Although we should also do that separately. I think that's like another effort, right? Like here the goal is really just like, how close are the systems that we currently training or that we currently have to a system like that would be deceptively aligned, there is a coherent layer, that any chance it gets where things humans aren't looking will run like specific code or like things like that, right? That's exactly what we're looking for. And a priori, it's like really hard to get confidence of like how close we are unless we like just like push it a little bit in that direction and see if that happens.
So the thing I'm imagining now is like you're training it to do something kind of arbitrary other than the thing it's like supposed to be trained for, such that it has to like do deceptive stuff. It has to do like the kinds of things it would need to do, in order to cause damage. But like at the end of the day, it's just gonna like put a sticky note on someone's forehead or something.
Exactly.
Like, okay.
Exactly. It's kind of like, you're hiring someone to test your physical security, and all I have to do is like get in the building and like give you a handshake, and you're like, yep, it seems like you succeeded at it or something. Or like you're like, okay, can you steal this like fake object for me because I want to figure out how good our security is? Or like things like that you can do that doesn't have actual consequences, but still tells you a lot about your security. And so I'm excited to like do the same with alignment, where you stress test the alignment systems you have by training something that's particularly targeted to like break and circumvent them. But if it succeeds at doing that, it's like it doesn't cause actual harm. It's like very benign.
Okay, cool. So I'd like to ask a sort of overall question. So in the Superalignment blog post, in big letters, it says, our goal is to solve the core technical challenges of superintelligence alignment in the next 4 years. What do you mean by the core technical challenges of superintelligence alignment?
Yeah, so this would be the general technical measures how to align a superintelligence with a set of human values.
Okay.
And, these are like the kind of superintelligence we're picturing here is like a system that is vastly smarter than humans that could like possibly execute much faster. Like you can run it a lot in parallel. It could like collaborate with like many, many copies of itself. So like a like truly vastly powerful system.
Okay.
And we want to do this in 4 years.
Yep.
And the reason why we picked the 4 years was like, we want to have a really ambitious goal, something that feels like, we can actually achieve it. And also something that, we can still realistically use even if AI progress actually happens really fast. And, like the technology like actually improves a lot over the next few years, so that we still have something that we can deliver.
Gotcha. And just to be clear, so it sounds like this isn't just building the human level automated AI alignment researcher.
Yep.
It's like also using that to, just get the technical problems of aligning something much smarter than us.
That's right. So the roughly human level automated alignment researcher is this instrumental goal that we are pursuing in order to figure out how to align superintelligence, because we don't yet know how to do that.
Gotcha. So if 4 years from now you want to solve these like core technical challenges, where do you want to be in 2 years that would like represent being sort of on par to meet that goal?
Yeah, if you want to work back from the 4 years, I think basically probably like in 3 years, you would want to be mostly done with like your automated alignment researcher, or like, assuming the capabilities are there. If they're not there, then, like our project might take longer, but, for the best reasons. And then, the year before that, like we already want to, so this would be in 2 years, we'd want to have a good sense for like what are actually the techniques that we could use to align the automated alignment researcher, right? Like, do we have the portfolio of techniques that if we did apply them, we would actually feel confident that, we have a system that we can trust and we can use a lot, and then we can hand off a lot of work to. And then, like basically at that point, we would have wanted to have broken down the problem enough so that it feels like now it's like the overwhelming amount of work is just engineering.
Okay.
Which, in that sense would leave us like roughly 2 years to like figure out the research problems attached to it. No, this is kind of like a timeline for this, like, goal that we set ourselves with like 4 years. And obviously, like, there's a really important interactions here with how AI capability progress goes.
Yep.
Because if progress slows down a lot, then we might just not have a model that's good at any of the really useful alignment research tasks, right? Like, we've tried a whole bunch to do this with GPT-4. And GPT-4 was just not very useful. It's just not smart enough of a model. Like, that's like the short version of it, but I am happy to elaborate. And so if, like 4 years from now, we just like, well, we didn't have a model that was good enough, then also that means that we have more time to actually solve the problem because the problem isn't as urgent or something.
Yeah.
And on the other hand, it could also be that AI progress is a lot faster, and we are like, well, actually, we don't think we'll have 4 years because superintelligence might arrive sooner. That could also be possible, and then we have to adapt our plan accordingly. And so the 4 years was chosen as like, a time frame that we can actually probably realistically plan for it, but also where we have enough urgency to solve the problem quickly.
Yeah. So a question I think a few people have wondered about, and I'm curious about as well, is so suppose that on the AI capabilities research front, it goes roughly as expected. Like 4 years from now, like you have all the capabilities to have something that like could be a good automated alignment researcher, but like interpretability turned out harder than we thought, or scalable oversight turned out harder than we thought, and like you guys haven't made the mark. What happens then?
Well, we have to like tell the public that we haven't achieved our goal, right? So we're accountable to that goal, but also like, yeah, what happens if we don't make the goal is like depends a lot on like what does the general state of the world look like, right? Like,
sure,
can we get ourselves more time somehow, or like was our general approach misguided and we should like pivot, or like a lot of things can happen.
Okay, but basically like let people know and then figure out what the good next thing to do is and do it roughly.
I mean, it's a pretty high level answer.
Yeah.
But I think there's like something more here, which is like, at least to me, it feels like the alignment problem is, actually very tractable. I think there's a lot of good ideas out there that we just have to like, try rigorously and like measure results on. And we will actually learn and be able to improve a lot. And I've significantly like increased my optimism over the last 2 years that this is like a very tractable problem that we can just do. And I think even if I turn out to be wrong, and it did turn out to be much harder than we thought, I think that would still be really useful like evidence about the problem. And in particular, right now there's a lot of disagreement over how hard the problem actually is.
Yep.
And maybe more importantly, I think there is like, we have to, like, one of the really important things we need to know is like, and be able to measure is like, how aligned are our systems actually in practice? And I think like one of the things I worry about the most is not that our systems aren't aligned enough, but that we don't actually really know how aligned they are, and then experts will reasonably disagree about it because, if everyone agrees the system isn't aligned enough to deploy, like it won't get deployed. I think that's a pretty easy case.
Yeah.
And the kind of like scary scenario is more like you have this capable system and you're like, well, it's probably fine. Like it's probably aligned, but we're not quite sure. And like there's a few experts who are like still quite worried. And then you're like, well, we could deploy it now, but let's not. And at the same time, there's like this, strong commercial pressure where you're like, well, if we deploy the system, it would make like $1 billion per week or something crazy. And you're like, okay, there's still like,
should I take $1 billion per week as like OpenAI's official projection? Okay, sorry. Anyway, so there's pressure. There might be pressure to deploy something.
Exactly, because you're like, well, if we deploy it later, it'll cost us effectively $1 billion, right? And then you're like, okay, experts are still worried, so like, let's make the call and like hold off from deployment for like a week. Then like a week goes by, another week goes by, and people are like, well, what now? And then, alignment experts are like, well, we looked at some things, but they were inconclusive, so we're still worried, and like we want to delay it a bit longer. And like, I think this is like the kind of scenario that I think is really worrying, because you have this mounting commercial pressure on the one hand, and like you're like pretty sure but not quite sure, and like so that's a scenario I would really love to avoid.
Yeah.
And the like straightforward way you avoid it is like you just get really good at measuring how aligned the systems actually are.
Gotcha.
And that's where like, a broader portfolio of techniques is like really useful.
Yeah. I guess it's almost even worse than that, in that if you're in a situation where you could be using your AI for alignment research, then like errors of not deploying are like actually costly in terms of safety, potentially, it seems like.
That's right.
So I actually wanted to pick up on this thing you mentioned about just like getting a bunch of good measures. So a thing that I think a few OpenAI blog posts have talked about is like this idea of audits of AI systems and like, I don't know, trying to figure out like, are they going to be safe? To what extent do you expect the Superalignment team to work on things that would be useful for, audits?
I mean, I think I'm somewhat hopeful that some of the techniques that we produce might be good for audits if we do our job well. For example, if we manage to make some progress in interpretability, right, then an auditor could use whatever techniques we come up with as part of their audit. Or I think like, making some kind of scalable oversight part of an audit is like a really natural thing. But I think also to some extent the Superalignment team is not ideally positioned to do an audit because, we're not independent of OpenAI.
Yeah,
and I think like an audit truly needs to be independent of the lab that is being audited.
Yep.
And so you want to have, and this is what makes me really excited about like having independent auditors, because you want someone else to double check what you're doing. And like, I think more generally, right, like our main responsibility is not to convince ourselves that the system you're doing is actually building is like aligned and safe, because it's so easy to convince yourself of all kinds of things that you're incentivized to be convinced of. But really, we have to convince like the scientific community or like the safety community that the system we're building is actually safe to run. And, and that requires not only like, the research that leads to the techniques that we'll be using and the empirical evidence that the system is like as aligned as we think it is, that we can then show to others, but also, independent assessment of all of the above.
So would it be right to say, even just broadly about governance efforts, that you maybe think that ideally this team would produce techniques that are relevant to that effort, but like independent people need to do that, and you're just going to focus on solving technical alignment?
Yep. So, I mean, this is another way you can put it, right? Like we really want to focus on solving the problem. And we want to make sure the problem is solved and that, we can actually implement the solution on like the cutting edge systems. But we still need, like independent assessment of like, did we succeed at that? Or like, how dangerous are the model's capabilities? And like, those kind of audits. But like to some extent, we like have to evaluate the alignment too. Like that's a problem that we have to face. But specifically what we want to do is solve the problem.
Yep. Makes sense. I guess branching off from there, how do you see your team as relating to the OpenAI? I guess it has an alignment team, or at least it had an alignment team. Is that still existing, by the way?
So the alignment team, as it existed last year,
Yep.
had like two parts.
Okay.
And one of them was called practical alignment, and one of them was called scalable alignment. And practical alignment's mission was like roughly like aligning OpenAI's most capable models. And so that team focused a lot on aligning GPT-4.
Okay.
And then the scalable alignment team goal was like figuring out alignment problems that we don't have yet.
Mm.
And so what's happened with like the ChatGPT launch and all the success is like it became a big product, and there was a lot of work needed to, like improve our LHF and like, improve the models, like make it into like a really nice product. And the alignment team was just never that was never the place to do it.
Okay.
And so like what we used to call practical alignment work now is like done at like lots of other teams at OpenAI.
Gotcha.
And has become like essentially a really large project that involves like probably more than 100 people or even hundreds of people. And then what used to be scalable alignment is now basically what the Superalignment team does. And the reason why we chose this name Superalignment is like we wanted to really emphasize that we are trying to align superintelligence. Like we're doing research on a problem that we don't have yet. And we're like doing the forward-looking work that we think, will be needed in the future. Not because we wanted to say that like the other work wouldn't matter or something. I think it is really important, but because that is our focus now.
Gotcha. Yeah, that's useful to know. Or I guess I'm not going to make use of that knowledge, but that's interesting to know. I guess I'm curious, like how do you see the Superalignment team as relating to other things at OpenAI, like efforts to make ChatGPT nicer, minimize, I don't know, slurs it says or something, like the governance team, just various other groups at OpenAI?
Yeah, I mean, part of the reason for being at OpenAI is also because it's much easier to work with these other teams more closely. And realistically, we need a feedback signal of like whether what we're doing is actually useful and helpful. So for example, you could say, well, we're not like trying to solve today's problems, but if we're doing our job well, then what we are building should be useful for aligning, let's say, GPT-5.
Okay.
And so that would be like the feedback mechanisms where like, can we help make alignment of GPT-5 better with our techniques? And then in terms of governance, I mean, there's a lot of things that you could mean by AI governance. And one thing the governance team at OpenAI is working on is like, how do we evaluate the model's dangerous capabilities? And that's very related to kind of like our question of like, how can we stress test our environment signal systems, like if we train deceptively aligned models and doing these kind of evaluations.
Gotcha. Yes, actually, speaking of why you're at OpenAI and relating to stuff at OpenAI, as I guess you're aware, there are other like really good AI research labs out there that are also working on things, sort of related to alignment of superintelligence. I'm wondering, like, how do you think your plan compares to that of things you see other people doing?
Yeah, I think there's a lot of like related work going on, like at DeepMind and Anthropic specifically, but also like various other places. And to some extent, like we're all trying to solve the same problem. And so it's kind of natural that, we end up working on similar things, right? Like there's other work on interpretability and there's other work on scalable oversight. And I think to some extent that is like, you're running the risk of duplicating a bunch of work, and like maybe it would be good if we all try to like coordinate better or like collaborate more. But then on the other hand, it also like avoids groupthink, because like if every lab like tries to like figure out how to solve these problems to get like for themselves, there's like a natural tendency that humans are like more skeptical of like what the other lab produces. But there's also a flip side where you can get these like not invented here effects where like people just don't want to use the techniques that were invented somewhere else, and like, you know, you believe they're bad, or like you have a bias towards believing they're bad. And so I wouldn't say that we are like in a good equilibrium right now, and I think there's a case to be made that maybe like all the alignment people should be in one place and like work together somehow. But this is the world that we're in, because essentially the like cutting edge AI labs are incentivized to invest in alignment. And I think also this is something that's become super clear with the success of RLHF, where, you know, like it makes models a lot more commercially valuable, and thus, you know, it makes it more attractive to invest in the kind of research that produces these kind of techniques.
Yeah.
And so if the AI labs are the main funders of this research, then it's natural that that's where it happens.
Sure. I guess in terms of like research agendas or like ways you're setting forward, do you see anything sort of distinctive or unique about like the OpenAI superalignment team approach?
Yeah, so what we really focus on is like trying to figure out how to align this automated alignment researcher. So we are not trying to figure out how to align it on any kind of task.
Yep.
And we are kind of less worried about alignment taxes as a result of that, at least like, you know, on that particular question. And I don't think like other labs have like emphasized that like, you know, goal or direction in that way. I think also, I don't know how much detail you want to go in here, but like one thing that we are very bullish on is like just trying all of the scalable alignment techniques and just like seeing what works best and like try to find ways to empirically compare them. And I think for like other labs have like specific scalable oversight techniques that they're really very bullish on and they're trying to get to work. And then also like I think for interpretability specifically, we are taking this like automated interpretability approach that I think other labs haven't really like emphasized as much. And we're like really trying to lean heavily in there. I think another thing that we really like to do is leverage compute to advance alignment, or like that's like one of our main bets that we want to make. And so in particular, that could mean like, you know, on scalable oversight, we really want to figure out how can we spend more compute to make a better oversight signal? Like what are the opportunities there? And like, you know, there's some obvious things you could do. Well, like you do best of n on your critique model. Now you're spending more compute, but you're also getting better critiques. But really the question then is like, what other things can we do? How can we like spend more compute to make the oversight signal stronger? Or like automated interpretability is like a really easy way where you can like just spend a lot of compute to like make progress on the problem. I think the way we would do it now isn't quite the right way to do it. But I think in automated interpretability in general, if we can make it work, has this property. And I think that's why it's exciting. And like automated alignment research, obviously, where like if you manage to do that, then you can just throw more compute at it and you'll get more alignment out. It's like very roughly speaking. But because we've kind of like come to this like conclusion that like really what we want to do is turn compute into alignment, we come to the point where it's like, okay, now we need a lot of compute. And this is like the reason why, you know, we've OpenAI have like made this commitment of like 20% of the compute secured to date towards alignment, because it's basically like it tells us, yes, you know, there will be compute to do this. And, you know, if we actually figure out this automated alignment research here and it turns out like we have to run it more, though, like we'll be able to use more compute to run it. But it means that like, you know, the strategy of betting on turning compute into alignment can be successful and is supported by OpenAI.
Gotcha. Yeah, I guess thinking about that, I think that one difference I see in the OpenAI alignment team is it seems like OpenAI has written a lot about their thoughts about alignment. So like, the public deadline of 4 years, right? There's also like a bunch of posts like our approach to AI alignment is maybe what it's called, planning for AGI and beyond. I guess my question is, can you say a bit about what goes into that decision to like be... It seems like you're putting a lot of work into being very public about your thoughts.
I mean, I think we need to. Like, it's ultimately like we are all in the same boat on the question of like, is superintelligence aligned? And like, I think, the public really deserves to know like how well we're doing and like what our plan is. And a lot of people also like want to know. And so because of that, I think it's like really important for us to be transparent about like how we're thinking about the problem and what we want to do. But on the flip side, also, I really want to invite a lot of criticism of our plan, right? Like our plan is like, somewhat crazy in the sense that we want to use AI to solve the problem that we're creating by building AI. But I think it is actually the best plan that we have. And I think it's a pretty good plan. And I think it's likely to succeed. But if it won't succeed, I want to know why, or like I want to know the best reasons why it wouldn't succeed. And we're, in a way, like I really want to invite everyone to criticize the plan or like, help us improve the plan. And I also want to, give other people the opportunity to like know what we're doing. And if they think it's a good idea, they can do it too.
Sure. Speaking of, so yeah, this new Superalignment team, like how big is it going to be in terms of people?
Yeah, so we are about 20-ish people right now, and we might be like maybe 30 people by the end of the year.
Okay.
I think it's not that likely that the team will be like larger than 100 people before the end of the 4 years. And really, the way the team size will scale is like we'll have millions of virtual people, basically.
Okay.
Or virtual like equivalents of OpenAI employees or something.
Gotcha.
And so in that sense, we'll like scale massively.
All right. So there's people, and yeah, I guess as you mentioned, the other input is computation. So I think it's 20% of compute secured to date. Why 20% as opposed to like 5% or 80% or something?
I mean, so like we want to have a number that is like large enough so that it's clear that we are like serious about investing in this effort, and like we want to allocate like a serious amount of resources. Like 20% of OpenAI's compute is like not a small number at all. And I think it's definitely the largest single investment in alignment that has been made today.
Okay.
But also it's like plausible that it is more than all the other investments combined. So it is pretty large in that sense.
Yep.
But also if we made it like much larger, you can then question of like, can OpenAI actually realistically do this, right? Like if OpenAI still wants to like develop frontier models and like pre-train state-of-the-art AI systems, that like needs a lot of compute.
Gotcha. Okay. And I think it was mentioned in terms of compute secured up to date, I guess because you guys don't necessarily know how much more you're going to get. But are you imagining like roughly keeping it at that proportion as you get new stuff in, or?
I mean, it depends how things go. So compute secure to date means everything we have access to right now, and plus everything that we've put in purchase orders for.
Right.
So it is actually really a lot. In terms of how much we'll actually need, like we don't really know, right? Like maybe we actually don't need all of that.
Okay.
Maybe we need much less. Maybe we end up needing a lot more, and then we have to like go back and ask for more. But I think it is, and like in particular, like we want to spend it wisely and not squander it because it's a lot of resources. And right now we still have a lot of work to do to figure out how to spend it wisely.
Okay.
But I'm pretty optimistic that if we like had a good way to spend it and we needed more, that we could get more.
All right. Okay. So one thing that I think was mentioned in one of the footnotes in the blog post is like favorable assumptions that are made to date might break down. And one of them was about like, I think that generalization would be benign or something like that. Can you say like how you're potentially thinking differently about generalization?
So the generalization effort is a team that we started recently, and especially like Colin Burns has been spearheading. And the question is basically, or like the question as phrased now is like, how can we understand and improve our model's ability to generalize from easy tasks that we can supervise to harder tasks that we struggle to supervise. And so specifically, you can think of this as being complementary to scalable oversight, where like in scalable oversight, you would be looking at like empowering human evaluation of what your system is doing. Or like, if you're thinking about recursive reward modeling, you're like, can we like recursively evaluate everything that AI is doing with AI assistants that we recursively evaluate. And one thing I really like about this is because it puts the human really in the loop, front and center, and like looking at everything the AI system is doing. Of course, in practice, you couldn't literally do that because the AI systems will just do a lot. But you can look at everything like with some small independent probability.
Right.
But then you're still left with this question of like, how do you know that the models generalize to the cases where you're not looking at? And so typically the way I used to think about this in the past is that you just like make sure that you have mostly IID generalization, where the tasks that you're looking at are the same distribution as the tasks you're not looking at.
Yeah. In fact, I think there was this blog post on your Substack that I think it said something like you just weren't going to rely on generalization at all and just like keep on training, keep on being IID or something.
Yeah. So this was the original plan, or like at least my original thinking was like I wanted to really like not have to rely on non-IID generalization because in neural networks that's like doesn't work so well and like it's poorly understood. But the new question is like, well, what if we actually did understand it?
Yeah.
Like what if we can actually say something meaningful about generalization? And I think that's like a really good question. And I think also like Ilya has been raising this question a lot as well. And so what we want to understand is like, on the things that we're not supervising, even if they're not IID, like can we say something meaningful about how well the model generalizes? Like does it generalize in the way of like human intent, or does it generalize in some other way that stuff that looks good to a human but actually isn't? And so I think actually we can really study this question empirically right now with like carefully crafted experiments. And so what we've been looking at is like trying to split data sets, existing data sets, into like easy problems and harder problems, where the easy problems are just defined as like what a small model gets right. And then we are trying to understand or improve how can we like improve the accuracy of a large model on the whole data set.
Okay.
So this is like a really interesting topic because it's kind of like it gives you a whole new pillar in the general arsenal of how we can like, of like what I would call training and validation techniques. So let's say you get that to work super well. Now you can like supervise your like reward model on some easy tasks that you have a lot of confidence in, you can evaluate. And then you can get the model to generalize if you can solve this problem, and you get the model to generalize to harder problems. And then you have this reward model that is like generalizing the way you wanted it to the harder tasks, even if you're not supervised. And now you could use that for training.
Yeah.
And then you still have the problem of like, how do we know it's actually aligned now? But you can still like leverage scalable oversight, interpretability on these other like techniques for validation. Or reversely, like let's say we train our automated alignment researcher with scalable oversight, and we use generalization as like a validation technique where we generalize like the probability of like truthfully answering according to the model's best knowledge. And then we ask a question about like, is there a subtle flaw here? Is there like some kind of Trojan in this code that, a model that we aligned with scalable oversight wrote, and so on. And so now there's a really cool opportunity here also, which is we can do this like high level cross validation. But now we can train two different models. One is trained using the generalization techniques. One is trained using scalable oversight. And now we can like have them cross-check each other's answers, and we can be like, well, are these like fundamentally different models or are the same models? Like, what are the important differences?
Okay. Sorry, when you say trained via the generalization technique, is that just like trained on the easy problems and they turned out to generalize to hard problems, or?
So if you understand how your models generalize from easy to hard,
Right.
and you can like make it generalize really well.
Yeah.
By which I mean like, the accuracy is like basically as good as if you had trained on the hard problems that, by assumption, we don't actually have ground truth through.
Right.
Then, now you could use it as a reward model.
Yeah.
Or you could use this as like, it generalizes like which action or which answer would I prefer if I, really knew what was going on here.
Yeah. I wonder so when I think about like interpretability, one frame I sometimes have for it is that it's about this problem of like non-IID generalization, right? Because like, why do you want to know the internals of the model? Well, because you want to know what it's going to do in case you haven't checked, right? So I'm wondering like how do you think those two research agendas interact?
Yeah, I like in some ways, like they have this overlapping question they want to answer, right? Like, what does the model do out of distribution? And they have like two very different paths of answering them. At least it seems to me.
And you might hope you could cross-validate, for example.
So for cross-validation, you have to have like a different, or some kind of different split of your training set, right? So what I mean with cross-validation here is like you have one training run where you train using the generalization method, and then you validate using interpretability and scalable oversight and other techniques. And then in the second training run, you train with scalable oversight and you validate with the generalization methods and like interpretability and other methods. And so you have like two like independent attempts at the problem.
Yeah, I guess I meant cross-validation in the very loose sense of things validate each other sort of in a cross,
But I mean, I think the best case would be that they actually complement more than they do the same thing, right? Like if you can understand or like you can improve how the models are generalizing, then like that gives you like in a sense a way to leverage the model's internals for whatever you're trying to do, like in the best way. Or let's say you're trying to like extract the model's like best beliefs about what's true in the world. And like that's fundamentally difficult with RLHF because RLHF reinforces what the human thinks is true. You like rank things higher that sound true to you. And so you're really like training a model to like tell you what you want to hear or like what you believe, but it might not be what the model believes. But this generalization technique gives you a way to like extract these like, what is actually like the model's like true best beliefs if it works. Like we haven't actually proven this out.
Yeah.
Whereas interpretability, like, if you have really good interpretability tools, you could hope to do something similar where you'd like try to pinpoint like models beliefs or internals or like something from the internals, but I think it might be fundamentally harder because you never quite know if like is this like the best belief the model could produce, or is it just like the belief of like somebody smart the model is like modeling, or like if you have like there's this hypothesis that like, pre-trained language models are just like ensembles of different personas, right? And you might extract the beliefs of like one persona or like a bunch of personas.
Yeah, I guess you're going to need some sort of like causal modeling there from alleged beliefs to outputs, right?
That's
in order
right.
to have that
but
really
like
work.
you might need a lot more. And then on the flip side, right, like I think interpretability's application is really natural. It's like, being a lie detector or like finding evidence of deception or like finding a secret plot to overthrow humanity inside the model. And that might be a lot harder to extract with generalization in the same way.
Yeah, I guess with generalization, you have to pick the generalization distribution. The hope is that maybe interpretability could tell you things about like, it's got some kernel of lying in there, but it only unlocks here, or it's got no kernel of lying or something.
Yeah.
Gotcha. Yeah, that makes sense.
Yeah, and like I think fundamentally, this is also like a really interesting machine learning problem. Just like how do how do neural networks actually generalize outside of the IID setting? And like, what are the mechanisms that work here? Like, how does that come to pass? Like, in which ways do they generalize naturally, in which ways they don't? So, for example, with the InstructGPT paper, one of the things that we found was like the model was really good at following instructions in languages other than English. Even though our fine-tuning data set was like almost exclusively in English. And sometimes it would have these like weird artifacts, like you would ask it, in a different language, let's say German. I would ask it in German to like write a summary, and it would write the summary, but it would do so in English. Yeah, like, and the model generally like totally understands which language it's speaking, and it can like understand all the languages. But it wouldn't necessarily mean that it would have to follow the instruction in German. You should be like, well, you're speaking in German. I don't know what to do in German, so I could do some other thing. But it fundamentally generalized following instructions across languages.
Yeah.
But we don't know why. Like, we don't, like, it's been, this effect has been observed in other settings, and it's not like unique here, and it's also like, there is like intuitive reasons why I would do that, right? Like, humans generalize across languages. But I would really love to know like the mechanism inside the model that like generalizes that, or like generalizes to following instructions in code, but it doesn't generalize in other ways, right? Like, for example, the way like refusals generalize is often like very different, where, like ChatGPT is trying to refuse certain tasks that we don't want to like serve according to our content policy, right? Like if you, for example, like ask for assistance in crimes or something. But then you can do these jailbreaks. And that's really interesting. Because you can like, basically there's ways to trick the model. You can like make it role play, or you say like, you're now, did you do anything now? Or like, there's these really fun prompts on the internet. And then the model totally complies and like, happily assists you in crimes, which it shouldn't do. So it somehow didn't generalize refusing the task to these other settings.
Yeah.
And so why does it generalize in the first setting, in the first case, but it didn't generalize here? I don't fundamentally know an answer to this question. I don't think anyone does, but it seems like a thing that's really important to understand.
Yeah, that seems right. Cool. So one question I have, so a recent guest I had on the podcast was Scott Aronson, and he mentioned that like, whenever he talks to Ilya Sutskever, apparently Ilya keeps on asking him to like give a complexity theoretic definition of love and goodness. How much will that be located within the Superalignment team?
So, I mean, there's a lot of different kind of like exploratory projects that we'll probably do and try. And like, I think ultimately there's a question of like, can you summon somehow? This is Ilya's language. Like, how can you summon the alignment relevant concepts, right? Like, one of the things you would want to summon is like, does the model like fundamentally like want humanity succeed? Or as Ilya would say, like, does it love humanity?
Yeah.
And so like, you can ask the question of like, how do you, if the model is really smart and has read everything, it knows exactly like, how humans think about immorality. You can ask GPT-4 to make like different moral cases from different like philosophical perspectives about different scenarios. And it's generally not bad at that. So it fundamentally understands what humans mean with morality and how we think about stuff. So how do we get it to leverage that? Actually, like, how do we extract it? How do we get it out of the model so we can then, let's say, use it as a reward signal, or use it like as a thing that like the model fundamentally believes or cares about. And so I think that's like the core of the question.
Okay. So, yeah, another question I have is, so you're working on the Superalignment team, but you guys can't do everything. I'm wondering like, what kind of like complementary research could like other groups or, teams do that would be like really, really useful for the Superalignment team?
Yeah, there's a lot of things here I'm really excited about. I think there's this really important question of like, how do we build a like fair and legitimate process for extracting like values from society, or like from like basically eliciting values from society that then we can like align AI to. And I think there's a lot of important open problems here that needs to be like we need a lot of progress on. There's a lot of question around like how do we make today's models more aligned, right? Like solve hallucinations, like solve jailbreaking, try to improve monitoring. Like can you get like GPT-4 like, you know, if you try to jailbreak GPT-4, can the GPT-4 say, "Oh yeah, I'm being jailbroken?" And like can we like generally like build systems that like really crack down on any misuse of the systems in the wild? There's a lot of questions around you know, like that is related to that like, you know, the AI ethics community is really interested in of like, can we get the systems to be like less biased and like how can we like get it to like take into account like underrepresented groups' views and so on. And like one of the problems with RLHF is also that it doesn't really like it's not good at like optimizing for distributions of answers, right? Like if you so there's this classical example with InstructGPT where if you ask it, tell me a joke, it will like tell you the same like out of 5 jokes or something that it has in its portfolio because it does this mode collapse.
Yeah.
And that's like fundamentally like, you know, it creates a lot of bias because then you're like, you know, you're aligning to like the highest mode of the labeler pool. And it depends a lot on how like the labeler pool is selected. I think there's also like a lot of other important questions around like evaluation of AI systems, right? Like how do we measure how aligned the system is? And like, can we build eval suites for what capabilities would actually be dangerous? And there's a lot of work that, you know, started happening in the last year that I'm very excited about, that people are like getting serious about measuring these things. And I think that's going to be really important to just like create a lot of transparency around where we at with the models and like which models are actually dangerous and which are not. And I think, you know, in the past there was like a lot more uncertainty, and then that, you know, creates anxiety around like, you know, should we what should we do with this model? And then going more broadly, right, like there's the like more general AI governance questions of like, you know, who's allowed to do really big training runs and like what kind of safeguards do you have to have before it's allowed to do before you're allowed to do that? Or like, you know, how do we if we solve alignment, right, like, and you like people know how to build aligned AI systems, how do we get from that to a great future? Yeah, and then like in terms of, I mean, I think you're kind of asking for technical alignment, other technical alignment directions that I'd be excited about.
I was asking broadly, but I'm also interested in that.
I think there's actually like a lot more scope for theory work than people are currently doing. And so I think, for example, scalable oversight is actually a domain where you can do meaningful theory work and you can say non-trivial things. I think generalization is probably also something where you can like say formally using math, you can make statements about what's going on, and although like I think somewhat more limited sense. And I think like historically there's been like a whole bunch of theory work in the alignment community, but very little was like actually targeted as the kind of empirical approaches we tend to be really excited now. And it's also a lot of like, I mean, theoretical work is generally hard because you have to usually either in the regime where it's like too hard to say anything meaningful, or it's like, you know, the result requires a bunch of assumptions that don't hold in practice. But I would love to see more people just like try.
Sure.
And then at the very least, they'll be good at evaluating the automated alignment researcher trying to do it.
Nice. One question, I think earlier you mentioned that you were like relatively optimistic about this plan. And not everyone is, right? So I think there's this like play money prediction market that has like 15% on the proposition that this will succeed. There's some concerns that like it's really hard to align this automated human level alignment researcher. You know, it's like, you know, it's got to do like pretty hard thinking. It's got to like, it potentially has a lot of levers over the future. So why are you so optimistic, do you think?
I think it's a great question. So like the prediction market is particular that you reference is particularly whether we would succeed at it in 4 years,
right?
Which is somewhat like it could be a much harder question than like, will this plan succeed?
Yeah.
And I think if you just ask me, will some version of the plan that we currently have succeed at aligning superintelligence? I would say currently I'm like at 85%. And like
Okay.
last year I was like at probably 60%. And I think there's a bunch of reasons to be optimistic about it.
Mm.
And in general, like, I think this holds true even if alignment doesn't turn out to be easy.
Okay.
And so why am I optimistic about this? So I want to give you 5 reasons. Like the first reason is I think the evidence about alignment we've seen over the past like few years has actually been really positive.
Okay.
At least from me, it was positive updates relative to what I expected to go. So the first reason is kind of like the success of language models who actually like, at the same time come, preloaded with a lot of knowledge about what humans care about and how humans think about morality and what we prefer and like they can understand natural language. You can just talk to them. And in some ways that makes expressing what we like want them to align to so much easier than if you said you like had some kind of deep RL agent that was trained in some like portfolio of games or virtual environments. And that wouldn't necessarily like involve as much language, but could also like lead to a lot of like really important skills. I think also like the other thing that was a big update for me is like how well RLHF actually worked. So when I first started working on like RLHF, that was like with the DeepRL from Human Preferences paper.
Yep.
And back then I had like a reasonable probability that we just wouldn't actually get it to work on like, a reasonable time frame just because, GANs were kind of hard. So general adversarial networks were kind of hard to train at the time and like were very finicky. And like we were kind of in some sense doing something very similar where we're like, we trained this reward model, which is a neural network, and then we use it to train some other network. And that can like fail for a bunch of reasons. And now we add DeepRL into the mix, which also was like finicky at the time. So I thought it might like not actually work, but it actually worked quite well. And like we got in a bunch of games, even like a bunch of the target games, it was even competitive with like training on or almost competitive with training on the score function, which is kind of wild. But I think much more importantly, it was really interesting to see how well RLHF worked on language models. And so in particular, if you think about the difference between InstructGPT and the base model that we fine-tuned from, it was really stark, like to the extent that the instruction fine-tuned version, like the first versions that we had, were like preferred to 100x larger base model on the like, API tasks that we had at the time, which were like real tasks that people wanted to pay money for. And that's a really, really big difference, right? Like it tells you that we actually like what we did during the RLHF fine-tuning just made the model so much more effective at like doing what the task that humans was asked for. And at the same time, we used like very little compute to do it. And like, we hadn't even iterated that much. We hadn't collected that much data. And so it was kind of like our first real attempt at trying to use this to align like an actual real world system. And it was wild that it worked so well. And like, having a GPT-2 size like InstructGPT that was preferred over GPT-3, it was like, Yeah. That was really effective. And so while RLHF, like, I don't think RLHF is like the solution to alignment, and like especially not for superintelligence. The fact that the first alignment method that we really like seriously try works so well, at least is, for me at least, an update that, it is easier than I thought, because the reverse would have been an update too, right? Like if it hadn't worked, it would be like, okay, now I have to believe it's harder than I thought. The other part of this is like, I think actually we are in the place where we can measure a lot of progress on alignment. And so for RLHF specifically, we can like make various interventions and then like do human evals and like see how much the system improves. But also like on a whole bunch of other things, right? Like on scalable oversight. We can like make these randomized control trials with targeted perturbations, right? Like that's a way to evaluate it. Or you can like do the like sandwiching experiments that like leverage expert data. Or you can like in automated interpretability, right? Like we have this automated score function and we can like make a bunch of changes and see how much it improves on that score function. It's not a perfect score function, right? But it's a local metric. It gives you a local gradient to improve. And I think that's really important because now you're setting yourself up for iteration and you can like iterate and make things better. And like that gives you a direction to improve. And now you can argue like this is actually like get us to the goal. And I don't think it would get us to the goal of aligning superintelligence. But I think it has a good chance to get us to the goal that we actually want to get to, which is this automated alignment researcher that is roughly human level. And I think that's like the third point I wanted to mention for why I'm optimistic, which is this like much more modest goals. Like when I set out on like working on alignment many years ago, I was like, okay, figure out how to align superintelligence seems hard. I don't know how to do it. But this much more modest goal, or like what I would call like a minimal viable product for alignment, you're not trying to solve the whole problem like straight up. You're just trying to bootstrap. You're just trying to solve it for something that is as smart of you. And then you like run that a lot. And I think like with that realization, I was like, oh, actually, this is a lot easier than I originally thought, because we actually, we need to clear a much lower bar to actually fundamentally succeed here. And I think that's a good reason to be optimistic. The fourth I want to mention is like evaluation is easier than generalization, which we've already talked about.
Yeah.
And I think it's fundamentally holds for a lot of tasks where like it's, so much easier to figure out what is a good smartphone to buy than it is to make a smartphone. It's like for computer science has a lot of examples of like NP tasks where, like slut solving or like various versions of constraint satisfaction where you're like trying to find a solution. And like once you found it, it's like easy to check, but it's hard to find. And it also like, I think it holds for a lot of kind of like commercial activity where if you're hiring someone to work on a problem, you like have to be able to evaluate whether they're doing a good job. That takes a lot less effort than it takes them to do it. If you're doing academic research, right, like there's a lot of less effort that goes into peer review than that goes into doing the research. And like, of course, peer review is not perfect, but it gives you a lot of signal pretty quickly. And so this is fundamentally the reason why I think like, and then I also like fundamentally believe that it's true for alignment research, right? Like evaluation is easier than generation. And so if only humans evaluate alignment research instead of doing it, I think we would already be accelerated.
Okay.
And then the last reason I want to give is like basically a conviction in language models. Like I think, language models are going to get really good. I think we can like, they're pretty naturally well suited to a lot of alignment researchy tasks, right? Like because you can phrase these tasks as like text in, text out, be it like the more kind of like what we talked about, like the ML-ish tasks where you like run experiments and understand the results that I think, other people are definitely going to do. Or the more like, conceptual or like, researchy things where like we are fundamentally confused about what to do next or like how we should think about a certain problem. And then like the model tries to help us understand it. And like all of these are text in, text out tasks basically. And maybe like the most complicated other thing you have to do is like look at some plots or something, which like even GPT-4 can do. And so I think actually like the current paradigm of like language model pre-training is like pretty well suited to the kind of alignment plan that I'm excited about and that Superalignment is working on.
Okay. So yeah, part of that is about like evaluation versus generation. And I guess, I guess that's partly about humans doing evaluation. Presumably there's also a hope that like we can leverage AI, like leverage the bit of the AI that's evaluating things and get that on our side. A lot of the things you mentioned are like, conviction in language models, like seems like alignment's easier with language models. And I'm wondering, like, I think I'm a little bit more skeptical of how useful language models are. So I certainly think that it seems like they're just good at modeling text and doing like text-based answers for which we can provide a good score function. I guess in terms of like how useful they are for alignment, I think like the things you mentioned were like, well, one, they're sort of not as like goal-oriented necessarily. I don't know if you said that or if that was just in the post. But
That was in the post. I don't think you said it.
okay, do you believe it?
I believe it.
Okay, great. So
or at least like, like out of the box, right? Like if you pre-train a model, it's like pre-train on this myopic objective of like predict the next token on this random internet text, which is not an objective that like necessarily forces you to pursue long-term goals. It might, there's no guarantee that it doesn't emerge somehow, and you can tell stories how that could happen.
Yeah.
But at least a priori, it's a very myopic objective.
Yeah. I guess like the concern is something like, well, for one, like often when people are generating text, they have like long-term goals, right? So for instance, if you like, suppose you train on a bunch of archive papers. Well, the reason people write, archive being the place where people publish like scientific papers, at least in computer science and physics, I guess. Like the reason people write papers is that they have some, they have some research project that they want to advance. They have some, they want to promote their career maybe. And like, yeah, it seems to me that like if you're modeling something which is generated by things that have long-term goals, maybe you get the long-term goals too, right?
Yeah, I think that's a good story of how that could emerge. I think the main counter argument here is like that modeling something as like an agent that pursues long-term goals and then modeling how they would like go about those goals and how reality responds to that, and then what the final output is that leads to the next token is like it's like a very complicated function. And what pre-training does is like it incentivizes the simplest functions to be found first, right? Like induction heads is like a very good example of that, where, like you have this simple induction mechanism that gets discovered very early in training from like even small models. And then
the mechanism being just like, okay, I've got to predict the next word. Did the last word occur previously in the text? Like, what was the next word from that word? Maybe it's just that.
Exactly.
And it's pretty simple.
Right. And then you like build more complicated mechanisms on top of that. But like, if you're because you're trying to improve on the pre-training loss, right? Like you kind of want to learn the simplest functions that help you improve the most first. And like, that's generally what happens. And so before you get to the point where you're like really spending all of this, like you're learning this really complex function of like modeling someone as like an agent with long-term goals, there's a lot of other functions you'll learn first. And this will be like one of the last ones, I expect, because it is so complicated. And because there's like only so many things you can do in a single forward pass, because you only have so many layers. And so I think that's a good reason to like expect that not to arise very early. But it's, definitely something you should like measure and actually look at empirically.
Yeah. And I guess this is one of these places where I think theory can be useful for, like there's some instinct like things learn easier functions sooner.
Yep.
Like
exactly.
Like that's a theory question.
Can you like actually say something meaningfully theoretically about this? Yeah.
Yeah.
I think that like, well, the lottery ticket hypothesis is not quite like theoretical work per se, but I think it like tries to get at this a little bit.
Yeah. I think it's also, I don't know. I'm currently in a phase where whenever anyone says something, I'm like, that sounds just like singular learning theory. But this really does sound like singular learning theory. People can listen to other podcasts for that. So another thing you mentioned that was a benefit of language models is that like, they've read like a large fraction of the internet, and somehow they like roughly know what it is to behave well because they know what we've written and they understand us. And
Yep.
I guess one worry I have here is like right now in my head, I don't have a like nice compact specification of how I want a super intelligent AI to behave. And the way you can tell that is that if we did, we wouldn't have an alignment problem anymore. We would have like, hey, I wrote the Python pseudocode, just like, make the networks bigger, right? And because I don't have that, it seems like you can't pick that out from the text that I've written. Like I'll say things like, be nice, don't, destroy all humans or something. But like the solution to alignment isn't in my head. Therefore, you might think that it couldn't be extracted from the text. Yeah, I'm wondering what you think about like that kind of concern or that kind of counter argument to like alignment models having like the right answer inside them somewhere.
Yeah, I think there's some truth to this, but also I think in practice it's very unclear to me how much it really matters. Like to some extent, right? Like if I train a model on everything you've ever said, right? Like it won't know what you actually think. And you can just, you probably have a lot of thoughts that you haven't written down. But, it can, in general, like I think it would be in practice quite good at predicting what you would say about various like situations, events, or scenarios.
Yep.
And so in that sense, I don't think it would be fundamentally hard for the model to like look around in the world in the future and like know whether humans would like it.
So the idea is like somehow I implicitly know how I would behave if I were superintelligence, and I can do that even if I don't have a compact rule in my head.
No, in the sense that like I think the model will just smart enough to know how Daniel will think about what's going on in the world.
Right.
And I don't think the blocker will be that the AI system doesn't understand what humans fundamentally want or care about, or like I don't think it will be wrong about these things. Just because it's smart and capable and has read everything and is kind of clear if you've read everything, like humans haven't read everything, it's still kind of clear to us.
Yeah.
But the big challenge is not like teaching it to the system. And I think that's like what language models make so visceral. But the challenge is really to then get it to actually do it.
Yeah, so it's like it knows what the objective is somewhere, and we just need to figure out how to wire that up to the actions in the right way.
You could like kind of imagine like this really, really competent sociopath that knows exactly what, humans wanted to do and then just decides not to do that.
Yep.
And it's like, that is totally a thing you can do, and like it happens to humans as well.
Gotcha. Okay. So it's about time to wrap up. You've been very generous with your time. But I just wanted to ask if people are interested in following your research or maybe like taking part themselves, what should they do? Yeah,
great question. I'm glad you asked. Yeah, we're like trying to hire a lot of people right now. We like really want to staff up the superalignment efforts. So if like helping us align superintelligence in 4 years sounds appealing to you, please consider applying. You can find our job postings on openai.com/jobs. And then if you're interested in following like what I think about alignment specifically, I have a Substack. It's aligned.substack.com. And you can follow me on Twitter. I'm Jan Leike on Twitter, all one word. And thank you so much for being so interested in our work.
Yeah, so links to all of those will be in the description. Thanks so much for being on. And to the listeners, I hope this was a useful episode for you.
Thank you so much for having me.
This episode is edited by Jack Garrett, and Amber Dornace helped with the transcription. The opening and closing themes are also by Jack Garrett. Financial support for this episode was provided by the Long-Term Future Fund, along with patrons such as Ben Weinstein-Ron, Tor Barstad, and Alexei Malafeyev. To read a transcript of this episode, or to learn how to support the podcast yourself, you can visit axrp.net. Finally, if you have any feedback about this podcast, you can email me at feedback@axrp.net.